do, we're actually going to split up tree diagrams into a 3-part series, okay? What I'm first going to do is introduce tree diagrams, talk about all the symbols, talk about how everything is going to be calculated, the unions, the intersects, the givens, and that kind of stuff. Then we'll do an example of a tree diagram, so we'll start from the very beginning. We'll have a word problem, and from that word problem we'll set it up and solve for whatever we're looking for. Then in our last video is a problem that gives a lot of people trouble. In our last video we're going to do one where we pull maybe a marble, or we'll pull a marble out of a jar, place it into a box, and then pull out of the box. So it'll be kind of like those transfer tree diagrams. Those give a lot of people trouble. We'll save that for the very end. Let's make sure we understand the basics. Then let's make sure we can set up a tree diagram. Then we'll get into our hardest type of problem. So there's a couple of things I want you to notice about this tree diagram that I made right here. So our first branch is going to have A, B, C. And then your second branch is going to have a D and an E coming off of each letter, coming off of the A, B, and C. What I want you to notice is that every branch adds up to 1. Okay? Every one of these branches. Notice the first branch, the A, B, C. Notice how if we added these all together, they go to 1. Look at the first D and E, 0.2, 0.8. That adds up to 1. 0.3, 0.7, 0.4, 0.6. The point is every branch will always add up to 1. Okay? And then finally, the last thing I want you to notice is that see this DE right here, the second branch? Notice I have DE on every single one. If I went to another branch, then we would have the same thing going for each one over here. So this D and E, you'll never, how do I say this? Your second branch will never be different going down on the second row, same with the third row, and so forth. So let's talk about how we're going to solve a couple of these. What if, for example, I wanted to find the probability of A? To find the probability of A, you would just go to A and see that this is 0.1. So the probability of A would be 0.1. What about the probability of D? Notice I have 3 D's in this tree, and they're all on the second tier, I guess, second branch. The way you're going to find the probability of D, the probability of anything on the second level, is you're going to multiply across. So like, for first off, I'm going to go the probability of 0.1 times 0.2. But then whenever I lift my pen or my pencil and start back to the beginning, you're going to add. Then you'll go across B over to D. You'll multiply when you go across. You lift your pencil and come back to the beginning plus, and you multiply across. So for example, probability of D is going to be 0.1 times 0.2. So it'll be 0.1 times 0.2. Then you have to lift your pencil to come back to the beginning because you need to take every D into account. So plus, then I multiply across 0.4 times 0.3. So 0.4 times 0.3. Then you have to lift your pencil again and come across this branch. So you multiply when you go across 0.5 times 0.4. 0.5 times 0.4. And that would be your probability of D. Now, let's talk about the next one, the probability of B intersect E. Whenever you have the intersect of anything, all you're going to do is multiply across, period. So the probability of B intersect E, you just do multiply across the B and the E. So B is 0.4 times 0.7, period. Remember, with the intersect, you just multiply across the B and then to its E, so 0.4 times 0.7. So now let's talk about unions. The probability of A unioned with B. Okay, remember, because it's a union, this is going to be the probability of A plus the probability of B minus the probability of A intersect B. Okay, well the probability of A is just 0.1, plus the probability of B is just 0.4, minus the probability of A intersect B. Well, A never intersects with B, because what did I just talk about with the intersect? In order to intersect, you have to multiply across, but A intersects with D and E. Same with B. B intersects with D and E. So A intersect B is just 0. It has no intersection. And so it's just the 0.1 plus 0.4. Well, let's take a look at the next one. What if I did C unioned with D? If I want to do the probability of C unioned with D, this is going to be the probability of C plus the probability of D minus the probability of C intersect D. All right, so let's come over here. So the probability of C, 0.5. Okay, so we have that 0.5. Plus the probability of D. Notice how I have a D everywhere. You need to take all the D's into account. And we already have that taken into account over here. We already have the probability of D, right? You have to take every single D into account. So I'm just going to say over here, just probability of D. Okay, but that's all what this line is. Probability of D is just all of this minus the probability of C intersected with D. Well, how do we find an intersect? We multiply across the branch. And so C intersected with D would be the 0.5 times 0.4. So minus 0.5 times 0.4. Okay? Let's now come over here. Now we're dealing with the givens, okay? And remember Bayes' formula, the givens from your other separate video. If I want the probability of D given A, well, remember the second part, this is my sample space. What this is going to be, this is going to be the probability of D intersected with A divided by the probability of A, right? The probability of my sample space. And so the probability of D intersected with A, you just multiply across. If it's D intersect A intersect D, tomato, tomato. So D intersect A is just the 0.1 times 0.2, 0.1 times 0.2, divided by the probability of A is just 0.1. And so notice how these 0.1s cancel. Right, these 0.1s are going to end up canceling 0.2. Cool. And for our last one, the probability of B given E, okay, using Bayes' formula, is the probability of B intersected with E divided by the probability of my new sample space, probability of E. Okay, so let's go ahead and figure out what this is. If I want the probability of B intersected with E, we multiply across, so B intersected with E, that's 0.4 times 0.7. So 0.4 times 0.7 divided by the probability of E. And notice how E is in my second tier, and you need to take E into account, all the E's into account. So the probability of E, I multiply to get across, so 0.1 times 0.8, 0.1 times 0.8, plus, then I got to multiply across the middle to get to that E, 0.4 times 0.7, so 0.4 times 0.7, plus, and I got to take one more E into account, and it's a 0.5 times 0.6. 5 times 0.6. And then you would just put this into your calculator. Okay? And for our last one, let's just say you want to do the probability of A complement. Heck, the probability of anything complement. What I would do with these is just do 1 minus the probability of A. Honestly, that's all I would do. For all of these complements, the probability of E complement, that's 1 minus the probability of E. And so forth. That's how you're going to attack all of these. Now this is really important to know how to do all of these commands, because what's going to happen is in the word problems, we're going to first set up that tree diagram, then based on the question, set up my command as to what I need to do, but you need to be familiar how to find the probabilities of something either on the first branch or second branch. You need to know how to do the intersection. Remember, the intersection, you just multiply across that branch, so B intersect E, you're multiplying across the B and the E. For union, remember this formula we learned way back when, the probability of each individually added up minus the intersection. And then for givens, this is our new one, this is what we learned in the previous videos, Bayes' theorem. It's going to be the probability of the intersection between the two divided by the probability of my sample space, my new sample space. Okay? And then finally, if you have a complement, just do 1 minus the original. So make sure you have this down. Join us in the next couple of videos because we're going to have word problems we'll set it up and do the whole 9 yards.